Okay, student notes, video lesson 5.1, reciprocal quotient and Pythagorean identities. This is the first day of Unit 5, which is trig proofs, and by now you've probably formed an opinion about what trig proofs are, although we're going to take it slow, so on this first day we're just going to do some basic stuff and kind of just build on what we already know. Okay, so when you see this word identity, it's kind of like formula. It's just true statements, rules, so to speak. So we already know that cotangent of x is the same as 1 over tangent of x. Cotangent and tangent are reciprocals. So it makes sense that when you multiply them together, you will get 1. As we're going through a trig proof, if you can spot something like this inside the proof and replace it with a 1, it simplifies the expression down, and that's something that we are going to want to do. Occasionally we're going to go backwards and we're going to see a 1 and we're going to make it into something more complicated. That's not really for today. We'll work our way up. But things equaling 1, big in trig proofs, so pay attention to that. So it's the same thing with cosecant and sine. They are reciprocals, so when you multiply them together, you will get 1. Secant and cosine, same thing. You multiply them together, you get 1. All right, now these here, very similar. And we have already talked about the fact that tangent of x equals sine x divided by cosine of x. This is a very important identity that you're going to use on maybe every other trig proof once we work up to the complicated ones. So it's worth remembering and memorizing if you don't already know it. And so that speaks then that cotangent of x, the reciprocal of tangent, would be the reciprocal of its identity. So instead of sine over cosine, it's cosine over sine. Okay. So let's prove these following identities. We already have enough information to start these trig proofs. Now, it's almost always easier when it just says prove and you see an equation, it's almost always easier to start with the more complicated side. Okay? So I am going to start with the right side, which is secant of x over cosecant of x. And what we're going to do is we're going to write a series of statements, and I'm going to simplify it down until I have just tangent of x left. Okay, so what's the only thing I know is equivalent to secant of x? 1 over cosine x. It's the only thing I know right now. And cosecant of x would be the same as 1 over sine of x. Well, I know I saw the identity that related sine and cosine to tangent, so let's think about what this would mean. And I'm going to go ahead and really make sure that this is really clear to everybody. When you're dividing fractions, remember that's the same as multiplying by the reciprocals. So this would be the same as multiplying by sine x over 1. Alright, I'm going to go ahead and go to the next line. If I multiply straight across, I get sine x. If I multiply straight across in the denominator, I get cosine x, and I have an identity that says sine x divided by cosine x equals tangent of x. I didn't skip steps. I didn't assume anything. I wrote it all out. That's the whole point of the trig proof. The trig proof isn't asking you if these two things are equal to each other. They're telling you they're equal. You have to write out each step, never assuming that the reader of your proof, even though that will be me most of the time, you don't assume that I know what you mean. You have to write it out. Now at the end, you can do a little check mark. You can do a happy face. You can write this little QED. If I remember correctly, this is quod erat demonstratum, which is Greek for it was to be proven or something like that. I'll have to look that up and tell you guys in class the next time. But a simple check mark is fine. Okay. So if you think you can try the next one on your own, go ahead and pause and see if you can do that. It's a very similar proof. Let me switch up the color here. So I'm going to start on the more complicated side just because that's going to be easier. I know that cosecant of x is 1 divided by sine of x. I know that secant of x is 1 divided by cosine of x. And very similarly, I'm going to do this division by multiplying the reciprocal of the denominator. If except this time cosine x times 1, or just cosine x, is in the numerator. Sine x is in the denominator. This is an identity now. We can assume this to be true. Equals cotangent of x. There we go. We proved it. And some proofs are as simple as this. They do get a little bit more complicated, so let's come up with some more identities. Okay. Okay, Pythagorean identities. First off, remember that with Pythagorean identities, or with Pythagorean theorem, let's just recall what Pythagorean theorem is. In this circle, Pythagorean theorem would be x squared plus y squared equals r squared. And in a true unit circle, r is always equal to 1. But the reason we call it the unit circle is because it's a circle with radius of 1 unit. All right, also remember that with this theta, let's take sine theta using SOHCAHTOA. Sine of theta would be opposite, which is y, over the r, which is 1. So in this triangle, sine of theta is just y, or y is sine of theta. And likewise, cosine of theta is going to be the adjacent over the hypotenuse, which is x over 1, or just x. And I'm not going to go through the other trig functions here just yet, but we have enough information now to go ahead and do a substitution. So right here it has an x squared. Well, that's going to be cosine squared. And remember, when we square a cosine theta, you put the squared between the cosine and the theta, because otherwise it looks like you're squaring the theta. And here I'm really squaring the whole thing. All right, y squared, y is sine, so y squared would be sine squared theta, or sine of theta squared. And r, since r is 1, when I square it, I get 1. And this is the main Pythagorean identity. Now, truly, when you see this written out, generally it's going to have sine squared first. It doesn't matter too much, but if you remember what I said, that it's really nice when things equal 1. It makes simplifying happen pretty quickly when things equal 1. So sine squared plus cosine squared equals 1. But if they were flipped and cosine squared was first, that would be fine too. Before we move on, I want to write 2 other statements down. Other statements that you might find. Occasionally in a trig proof, you will see the statement 1 minus sine squared. So I want you to use this new Pythagorean identity, and let's think about what is 1 minus sine squared. That would be if I subtracted sine squared from both sides. It would be cosine squared. Likewise, 1 minus cosine squared, theta is equal to sine squared. Now, at this point, you should not be freaking out thinking, how am I going to remember all this? You don't have to remember all of it. I'm just putting things out there for you to think about. This box, though, is something that you should remember. If you forget, though, you can always go back to this. But we'll use this identity so much that it will just become part of your memory bank. Okay, 2 other Pythagorean identities can be obtained by dividing the main Pythagorean identity through by sine squared and cosine squared. So let's start. I'm going to start by rewriting the identity here. Sine squared, I'm going to go ahead and put x now. Sometimes we'll see theta, sometimes we'll see x. All right. Now, if I divide everything by sine squared, which I should be able to do and keep everything balanced because I'm dividing everything by sine squared x. Okay, sine squared, excuse me, sine squared divided, excuse me, sine squared divided by sine squared is 1. This is requiring that identity from the very beginning. Cosine divided by sine is cotangent. So if they're squared, that's just going to give me cotangent squared x. And the reciprocal of sine is cosecant, so this just gives me cosecant squared x. And this is another identity, and it can be rewritten like how I rewrote the other identities, where I make it equal to 1. We're not going to write all that down because it's just going to get a little messy for today, but let's go ahead and find the other identity. And rewriting the main Pythagorean identity, now let's divide by cosine squared. sine divided by cosine is tangent. So this would simplify to tangent squared x. Cosine over cosine squared, same thing, gives you a 1. And the reciprocal of cosine is secant, so this is going to give me secant squared x. Now, these two identities are not used as much, but still quite a bit. And if you ever forget these identities, you can easily come up with them the way we did just now. Okay, so we already are building on many identities. Eventually, I'm going to give you an identity sheet, and you're going to be able, because I'm going to keep giving you more and more. For right now, though, I mostly just want you to understand how we come up with the identities, not about memorizing. Some of these, though, you should have memorized, like the ones on the front and the sine squared plus cosine squared equals 1. Okay, so let's start by doing some other proofs that are a little bit more complicated than the ones we started off with on the first page. Notice, though, that this doesn't say prove, it says transform. When you see this word, it means that you have to go from this to this. You don't get a choice of which side to start on. They're saying basically you have to start with this side. So as we go through these transformations, or really these are kind of like building up to proofs, keep in mind the identities that we have. That's how we're going to simplify things. And we're also just going to use basic algebra. So if I've got to go from sine x times cotangent x to cosine x, then that means I'm going to have to do some replacements and some things are going to have to cancel. Okay, and I need to do this linearly. I can't be working all over the page. And those of you that have bad handwriting, you're going to have to step it up on this unit, because that is the problem. There is no answer besides all your work. That's what you have to prove. So I'm going to look at cotangent x. I can substitute that a few different ways. I'm thinking, though, that probably what'll be easiest is if I use the identity from that first page. Oops, sorry. Here we go. Cotangent x. I could use cosecant and secant. Okay. I could also use cosine over sine. Which do you think would be easier on this one? Sometimes you have a choice. You could go one of two ways, but usually one way is easier than the other. If I use cosine x divided by sine of x, really the problem is done, because this sine x is being multiplied by something and there's a sine x in the denominator. These two things cancel to a 1. I'm left with just cosine x, and there I proved it. I proved that sine x, whoops, did not mean to do that. I proved that sine x times cotangent x is equal to cosine x. It's really clear. Anybody reading my proof could understand where my steps came from, and there you go. So let's do the next one. Again, this is a transform, so I have to start with this side, and I have to prove it equal to 1. So this means that not just some things are going to cancel, but pretty much everything is going to cancel. So let's go ahead and rewrite the problem. You always have to rewrite what you're starting with. You can't just jump into the problem and start doing stuff. You've got to write it down. And let's write an equal sign. And let's make some substitutions. Generally, when you want it to simplify down a lot, you're going to leave your sines and cosines alone and try to change everything else into sines and cosines. That's a pretty good method. That will work most of the time. Alright, so let's leave our sine x as sine x. Let's change our secant x to its most basic thing. That's going to be 1 over cosine x. And as I write this, I'm going to make it clear what's in the numerator and what's in the denominator. And again, when I substitute cotangent x, since I already have this done, it would be easier to go ahead and use cosine x over sine x, and I can see clearly that everything's going to cancel to a 1. Some of you might be looking at this and thinking, well, if you had used the other identity, let me go back a couple of slides here. If you had used this identity, cosecant over secant, then the secants would have canceled, and then cosecant times sine would equal 1, and you're right. And I'm going to actually write that down for this one. So if you didn't catch what I just said, I'm going to write it down. But for the one we have, cosine over cosine, that's 1, and then sine over sine, that's 1, And there we go again. We proved it. Okay. Another way we could have proved this, I'm not going to do this on every problem, but on this one, from here, I could have, again, kept the sine x the same. I could have even kept the secant x the same. And I could have substituted in for cotangent, cosecant x divided by secant of x. So that the secants would cancel. Then you would be left with sine x times cosecant x. And this is an identity from the very first page, because those two things are reciprocals of each other. They equal 1. And so from right there. Okay, so you can assume the identities, but everything else you have to write out. And as we work our way up in these proofs, there's generally going to be more than one way to do it. Okay, so number 3, transform cosine squared x minus sine squared x to 1 minus 2 sine squared x. Okay, again, they're telling us we have to start with this side. So I rewrite it, and I write my equal sign, and I'm going to go ahead and switch colors just to make it clear where we're doing the new work. And look at what you're trying to get. I don't see any cosine in what I'm trying to get. So I need to do a substitution on that cosine squared. Maybe though leaving the minus sine squared is a good idea, because I have something that looks like minus sine squared. So if you remember that Pythagorean identity, I'm going to rewrite it here at the top. Sine squared x plus cosine squared x equals 1. Remember that I told you that you could isolate either the sine squared or cosine squared by doing a subtraction, and that's perfectly acceptable in these proofs. So to substitute in for cosine squared, 1 minus sine squared is totally fine. This is not assuming too much. This is an acceptable step here. So instead of cosine squared, I substituted in 1 minus sine squared. Now I can see how we get the answer, because negative sine squared minus sine squared, well, there's 2 of them. So that becomes 1 minus 2 sine squared x. And there we go. We proved it. Okay, so you start with one side, you do acceptable substitutions using the identities, and you get the other side. Okay, so next problem. Always start by rewriting. Don't jump into whatever you think you're supposed to do. Just rewrite it first. This is part of good proof notation. Alright, now I don't really see a substitution I can make, and in fact I don't know how really to go from cosine to sine if it's not being squared. However, I do know some algebra tricks. I know that this is a binomial times a binomial, and so you may have heard of this as the FOIL method or just binomial distribution, but everything needs to get distributed to everything else. So the 1 needs to be multiplied by 1. The 1 also needs to be multiplied by negative cosine A. Alright, the cosine A needs to be multiplied by 1, and that's a positive this round. And then the cosine A needs to be multiplied to negative cosine A. So that's negative cosine squared A. And I didn't mention this, but notice that our argument here, or our angle, is angle A. And that's fine. Just go with it. Alright, so clearly negative cosine A plus cosine A cancels. That's just like a negative x plus an x canceling. So let me go ahead and write what I have next. If you're ever unsure on if you should write it, then you should write it. It's always better to write it. If it's unnecessary, that's fine. But if you leave out something you're supposed to have, that's no good. Okay, so 1 minus cosine squared A. Well, this looks an awful lot like the Pythagorean theorem. So 1 minus cosine squared, that is sine squared, and that is fine. That's why we wrote out those two. And then there we go. We proved it. Okay, number 5. Alright, again, we're transforming, so we need to write what they give us. This time our angle is m. Cosine m minus secant of m squared. And I could probably make a substitution here with secant, although the fact that I have a binomial squared tells me, or lets me think, okay, maybe I should square this binomial, do the algebra, then maybe some things will cancel, maybe the substitution will be more obvious. All right, and this is why you have an eraser on your pencil, so that you can always go back if you need to. So what I'm going to do is I'm going to write this out. Cosine m minus secant m, this is an e, times cosine m minus secant m. And you need to write this out instead of just going straight into squaring things. Okay, so again, distribution. Cosine times cosine is cosine squared, and that's m. Cosine m times negative secant m, I'm going to go ahead and write it as minus cosine m times secant m. I know that I'm going to have some two things cancel here, but that's for the next step. I need to just write it first, then I'll simplify it next step. On the next part of the distributing, I have negative secant m times cosine m. And again, I know that these two things are going to turn into one. I'll get to that in the next step. Okay, and then I have negative secant m times negative secant m. That's going to be plus secant squared m. All right. Now, whatever is easiest to simplify, let's take care of that next. So I have, just rewriting my cosine squared m. Cosine times secant, if it's of the same angle, is going to give you a 1. That was our reciprocal identities from the first page. Then I have another minus 1. Then I have plus secant squared m. Alright, still, it seems like I'm pretty far away from my answer. However, I know that I can do some substitutions. I can turn this into minus 2 here. That's not as high a priority as you think because it's not canceling anything like as if this had been minus 1 plus 1. So I'm just going to leave this alone for now. But I know that I can take cosine squared m and change it into 1 minus sine squared m. And what that will do is at least that one will cancel with this one. And so I should probably do something similar to secant squared. Now I'm going to go back just a second and look at our secondary Pythagorean identities. Okay, right here, secant squared x is equal to tangent squared x plus 1. So I'm going to use that as well. So cosine squared is going to be 1 minus sine squared m minus 1 minus 1. And then secant squared m was the same as tangent squared m plus 1. Now if you notice, I have a positive 1, a negative 1, a negative 1, and a positive 1. Those are all going to go to 0. And I have what I want in my answer, a negative sine squared m plus tangent squared m. That's the same as tangent squared m minus sine squared m. And there we go, we proved it. And this is kind of more like what you can expect in the near future. Some of them will be easy like the other ones. This is more like a typical trig proof. Okay, more steps. But if you're using identities, you kind of just get led to the next step. Even if you don't know what the end looks like, you know what the next step should look like. All right, some problems like number 6 look a lot harder than they are. The fact that I have fractions here, that actually tells you what to do. So first, let's just go ahead and write this down. Secant x divided by sine x, which doesn't really simplify to anything, minus sine x over cosine x. Sine x over cosine x does simplify to tangent, although I can't even foresee how that would help me, so I'm going to forego that substitution. What I'm going to do instead is work on going from a fraction minus another fraction. I'm going to work on the denominators and get this thing into one fraction, and hopefully, well, I know this will happen, but hopefully it will be easy that it will simplify to cotangent. So if I have sine x is one of my denominators, cosine x is the other denominator, that's going to make my common denominator sine x times cosine x. So what I'm going to do here is I am going to do a little bit of fraction work, and I am going to make sure that the denominators are the same, and I'm going to write those first. Now, the first part, secant x divided by sine x. Okay, look how I changed the denominator. I multiplied the denominator of sine x by a cosine x. So that's what I need to do in the numerator. I had a secant x, now I need to multiply by a cosine x. Now look what would happen if I canceled the cosine x's out. I would get what I started with. So don't do that, because that's just undoing all your work. Okay, minus sign in the middle. Now let's look at the second part. I multiplied the denominator by sine, so that's what I need to do in the numerator. I had a sign, then I multiply by another sign. And again, if I canceled the signs out, I would have what I started with. Okay, it looks like all I did was make it messier, but this is setting up quite nicely for the next part. So since I have the same denominator, I'm going to go ahead and write this as one fraction, sine x cosine x. Okay, now what is secant x times cosine x? It's 1. All right, minus sine x times sine x. That doesn't really change into anything besides sine x squared. All right, and what is 1 minus sine squared? This is that Pythagorean identity I said we'd use a whole lot. That is cosine squared. So when I'm rewriting it into the next step, I can see that something cancels. Now, what I'm writing here, it may not seem obvious, but I'm going to break down cosine squared x into cosine x times cosine x. Now I can see that one of the cosines from the numerator divides by the cosine in the denominator into 1, and I'm left with cosine x divided by sine x, and that is cotangent x. And there we go. Okay, bring your questions to class.